In this question, we will draw the position time graph for a marble that was thrown at some height above the ground. So imagine it is at this height. It means that its initial position, that I can say y0, is not 0. So it is at some height. So when we will draw its graph, so we will not start it from 0. Okay, as you see in all the graphs, it's not starting from 0. Okay, now, because if it is a free fall motion, because in this question this clearly say if a resistance is negligible, it means that it is a free fall one dimensional motion in which acceleration due to gravity is negative g. Okay, so how the ball's position will vary? So ball will cover less distance in every next interval. Ultimately, the ball will be at rest at the maximum height. So this is a position where the ball's velocity is 0 meter per second. And at this point, the ball's velocity is maximum. So that is Vy. 0 is maximum. So how the position is changing, position you have seen in regular intervals of time, the position has not changed uniformly. In fact, there is a always, so it means that it will not be a straight line. Okay, it can never be a straight line. We see that its velocity is decreasing. So you see I'm now drawing a small arrow and then more small arrow, and then we eventually at the maximum height is 0. So it means that now from the slope point of view, you know that the velocity is the slope of the position time graph or the displacement time graph. So if the velocity is decreasing, which we have clearly seen that it will decrease, and even not only this, we have another evidence. With the help of this equation, you can see v phi 0 minus gt. If I put the value, so this negative gt, this gt is a factor which is continuously decreasing from the which is continuously reducing the velocity. Ultimately it will become 0 meter per second at maximum height. Okay, so we see that the velocity is decreasing, which means can I say the slope is decreasing. So slope cannot decrease in a straight line graph, so which means that this is not possible, as well as, so which is possible. So this is a position time graph. Let's see which one is possible. So we have seen that it's already have some displacement which is not equal to 0. It means it will not start from this, from the origin, and it will be a curved graph like this. Why? Because you can see in this graph, if I show you at just 1 or 2 points, that the slope of the graph is decreasing with the passage of time, because this tangent line is becoming less steep. So this is a point at which the velocity becomes 0, because this is a point when the ball reached maximum height. So now because this is a free fall motion, that's why it will be the same shape, but you see that it will be like this, because now it is showing us that the slope of the tangent line is increasing but negatively increasing, because when the ball will be now returning, so now velocity is downward and it is increasing negatively, which we exactly observe from our graph also. So the right answer must be option B.